Hello, Williams class. Welcome to today's maths lesson. It is the lesson for the 22nd of February, 2021. Your arithmetic for today's lesson is the following. 8 times 7. What is half of 160? What is 46 as a Roman numeral? 4/9 plus 2/9. 6 times 7. 16 divided by 8. Write an equivalent fraction for 5/12. 4,562 plus 2,432. 7,896 take away 2,342. 24 divided by 6. The answers. 8 times 7 equals 56. What is half of 160? 80. What is 46 as a Roman numeral? XLVI. 4/9 plus 2/9 equals 6/9. 6 times 7 equals 42. 16 divided by 8 equals 2. Write an equivalent fraction for 5/12. Now, your answer can be different to mine, but one example of an equivalent fraction is 10/24. 10 out of 24. 4,562 plus 2,432 equals 6,994. 7,896 take away 2,342 equals 5,554. And lastly, 24 divided by 6 equals 4. The learning objective for today's lesson. Can I subtract fractions with the same denominator? So by the end of this lesson, you will have learnt how to use a number line to subtract fractions, to take away fractions. What I would like for you to do to start us off is tell me which one is different. Off you go. Now, if I was to do this question, what I would first do is work out what each sum would be. So for example, if I look at the first one, 3/6 plus 3/6 plus 3/6 would be 9/6, otherwise known as 1 and 3/6. Let's keep going. 5/8 plus 5/8 equals 10/8, otherwise known as 1 and 2/8. The next one, 3/4 plus 3/4 equals 6/4, otherwise known as 1 and 2/4. The next one here, 5/4 plus 1/4 equals 6/4, otherwise known as 1 and 2/4. And now these ones are pictures that we want to write in fraction form. So the first one, let's look at how many have been highlighted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then look at how many parts make one whole. 1, 2, 3, 4, 5, 6, 7, 8. So 12/8, otherwise known as 1 and 4/8. The next one, let's count up the parts that have been shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then how many parts make one whole? 1, 2, 3, 4, 5, 6. Otherwise known as 1 and 3/6. Now, if I was to say which one is different, I would say that this fraction is different. So it's 10 out of 8 or 1 and 2/8. Now, the reason why I think it's different is because this fraction, this fraction, this fraction, this fraction, and this fraction can all show, or they all do show the same thing, which if you simplify these fractions even more is 1.5. So every single fraction apart from this one tells me, or is a way of showing me 1.5. So that is why this one would be different. Question. Harry takes 2 identical strips of paper and folds them into 8ths. Explain how he can use these pieces of paper to find the answer to this subtraction. Now, the first thing I would do is I would look at the first fraction because it's the bigger fraction. It has the bigger numerator, which is 12. 12 is bigger than 5. So you always start with the biggest number. Even when you subtract normally, for example, if we do 12 take away 8, you don't do 8 take away 12, do you? You do 12 take away 8. So similarly, when you're subtracting fractions, always start with the bigger fraction or the fraction with the bigger numerator. Numerator, remember, is the top number. So we're starting off with 12/8 or 12/8. I'm going to start by shading in 12 parts. I'm going to get my highlighter just to make sure that I can do this nice and quickly. So shading in 12. Ooh, 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. Right, now 12 parts have been shaded there. What I'm then going to do is take away however many I'm being asked to take away, which is 5. Look at the numerator of the second fraction to see how much you're taking away, which is 5. So now I'm going to cross out 5. 1, 2, 3, 4, and 5. Now, how much or how many parts do I then have left over? I have 1, 2, 3, 4, 5, 6, 7. I have 7 left over. So 7 is my numerator. And remember, when you're subtracting fractions, when you're working with fractions that have the same denominator, the denominator does not change. So the denominator stays 8. So all in all, our answer is 7/8 or 7 out of 8. Fold 2 identical pieces of paper into 8ths. So using one paper, fold it 8 times. Use your strips to subtract these fractions. So I would like for you to have a go at folding paper yourself and then using that to solve these fractions. Now, your pieces of paper should look a little something like this. So let's do this bit by bit. 6/8 take away 3/8. Now, what I would like for you to do, what you should have done, is fold your paper so that you have 8 parts to it. Then you shade in 6, because remember, you look at the bigger fraction first out of the 2, which is 6 out of 8. You shade in 6 parts and take away 3 parts to then get your answer of 3/8. The second one, 9/8 take away 4/8. Now, because we had 9 parts to shade in, you needed 2 pieces of paper. You shade in 9 squares and you take away 4 of them to then get you the answer. I'll write it here because of space. 5/8, because 5 parts are left uncrossed. And your last one, 14/8 take away 5/8. So you get 2 pieces of paper, fold them so that you have 8 parts to each piece of paper. You shade in 14 of those parts and you take away 5 to then get your answer of 9/8, which is also the same as 1 whole sheet of paper with 1 part of another sheet of paper shaded in. So that's 1 whole and 1 out of 8. As an extension, if you would like to, you can fold 2 strips into thirds and then into half. Open them out and then write 4 subtractions that you could use your strips to solve. So that's a little challenge there for you if you feel like you can do these 3 very easily. Another example here, using bar models to subtract the fractions. So I think you'll find when you're making these strips with your pieces of paper, they look like fraction bar models. If you look at this question here, 10/6 take away 5/6. So our denominator always tells us how many parts we are dividing our strip into. So the denominator in this question is 6. So your strip should be divided into 6 parts. You might need more than 1 strip, as you'll see with this question, because if we have to shade in 10 parts, 10 is bigger than 6. So you need another you need another strip that's divided into 6 parts. So then you can easily shade in 10 of those. So shade in 10, which you can see here, take away 5 of them, and then you should get your answer of 5 out of 6, because 5 parts of those 6 parts have been left uncrossed. Another example here. Complete the bar models to subtract the fractions. What are our steps? So your first step is to shade in. How many parts do we have to shade in? 9, because that is the bigger numerator. Shade in 9 parts. So that, if that's our first step, what would our second step be? How many parts do we have to cross off? 1. Then we write cross out 1 part. Lovely. And then lastly, solve the question. Just like that. So I've managed to put into 3 steps how we subtract fractions with the same denominator. When you're writing your own steps, if you are choosing to write out your steps, you might have fewer steps, you might have 2, or you might have more than 3. That's completely up to you. Whatever makes it as easier as possible for you to solve this, to solve subtraction questions with fractions, go with that. So let's follow our steps. We shade in 9 parts, which we've done here. Number 2 is to cross out 1 part, which we've done here, and then solve the question. So what is 9/8 take away 1/8? The answer is 8/8, also known as 1. Because as you can see by our fraction bar model, an entire bar model has been left uncrossed. So rather than write 8 out of 8, we can just write 1. Here, sketch bar models to help subtract these fractions. So just like you did over here, you can get your pieces of paper again to work out these 3 subtraction questions. Off you go. So your fraction bar models should look like this. If they look a little bit different, that's okay, but if you get the same answer in the end, only then is it okay. Otherwise, obviously, keep watching to see how we draw these. The first question, 9/3 take away 4/3. So the denominator tells us how many parts our strip needs to be divided into, which is 3. Then you shade in 9 of those 3 parts, which is all of them here. Take away 4 of them to then get your answer of 5 out of 3, because you can see that 5 have been shaded and our denominator just does not change. Number 2, 11/4 take away 3/4. So our strip has to be divided into 4 parts. 11 of those parts need to be shaded in, and 3 of those parts needs to be crossed out or taken away. You should then get your answer of 8 out of 4, otherwise known as 4 out of 2, otherwise known as 2. And you can see here 2 whole parts of our bar models. 2 of them have been shaded in or have been left uncrossed. So you could just say 2 rather than 8 out of 4 or even 4 out of 2 when you're simplifying. And lastly, question number 3, 25/16 take away 7/16 equals. So your strip needs to be divided into 16 parts. 25 of those parts needs to be shaded in, and 7 then of those parts need to be taken away. You should then get your answer of 18 out of 16, otherwise known as 9 out of 8 if you wanted to simplify. And I think that's how much you can simplify. So that is how you subtract fractions with the same denominator using the bar models. This question, Sam says 11/9 take away 7/9 equals 4 zeros. What mistake has Sam made here? Now, if I was to answer this question, I would say that Sam has subtracted the denominators, which he should not have done. He should have left the denominators as they are to then get his answer of 4 out of 9, not 4 out of 0. your independent tasks. You have 3 different questions to complete. Off you go. When you unpause the video, we will then go through the answers together. Here are your questions. Number 1, A. 5/7 take away 3/7 equals 2/7. Question B. 7/9 take away 4/9 equals 3/9. C. 7/10 take away 3/10 equals 4/10. D. 6/6 take away 6/6 equals 0. E. 8 out of 93 take away 2 out of 93 equals 6 out of 93. F. 8/3 take away 4/3 equals 4/3, otherwise known as 1 1/3. G. 9/5 take away 4/5 equals 5/5, otherwise known as 1. Question number 2. Part A. 10/11 take away 3/11 equals 7/11. B. 10/11 take away 7/11 equals 7/11 take away 4/11. C. 15 out of 4 take away 7 out of 4 equals 2. And D. 11 out of 4 take away 3 out of 4 equals 11 out of 3, otherwise known as 5 out of 3. Question number 3, our third and final question. Alex and Annie are taking turns playing a computer game. Annie plays for a total of 2¼ hours. Annie plays for 3/4 of an hour more than Alex. How much time do they spend in total playing on the game? So what I did here is I changed 2¼ to another fraction, which is 9 out of 4. And then I added 3/4 to it to then get 12/4, which is otherwise known as 3. So in total, they spent 3 hours on the game. That is all for your maths lesson for today, boys and girls. I hope you enjoyed. I hope you have understood how to subtract fractions with the same denominator a little bit better. And you will now see me in your next video. I'll see you very soon. Bye.